In this video, we're going to integrate sine squared, cos squared. We are going to integrate sine squared, cos squared. Now, if I were to give you, let's say, one of the two being odd, this one here is an odd number, we can always rewrite this in this form here, where this is the derivative of this thing here. If we can get into this form, we know it's going to be easy to integrate. As it turns out, this thing here is really easy to integrate. This one here is much harder. Because even, well, if you've got an odd number, you can extract one block of cos. So extract one block of cos, and then the rest, cos to the power 4 can be written as this. So now you can 1 minus sine squared of x equals cos squared of x. You can replace this and put it into here. And the point here is that this thing here, because this is odd, you can rewrite it in this form, where this thing here is f of x, and this thing here is the derivative of f of x. So this, if you have an odd number, you can always extract one block of cos. Here you've got even, so you can't really extract one block. If you extract, let's say if you extract one block, let's say this thing here, cos x, and then sine squared x, there's no way you can rewrite this, there's no way you can rewrite this all in terms of sine, because you need a cos squared. You need a cos squared in order to convert it into sine. This is actually harder to do. Even if you have two odd, let's say this is an odd power, this is an odd power, you know you can rewrite it in this form. Because if it's an odd power, you can always extract one block of cos or one block of sine. It doesn't really matter. But you can rewrite this as a block of cos, and the rest will be cos squared to the power 4. And then you can convert this block into this. And then now everything is in terms of sine, and this is the derivative of sine. The point is that if you have an odd number, you know it's going to be easy to integrate. But our case, we've got an even and an even. We've got an even and an even, so it's going to be much harder. We've got no choice but to use these two. So to integrate this, put this into the sine, put this into the cos. That will then take us here. Here you've got two fractions. Factor out the quarter, and now all you've got is the numerator, which is this thing here. So now multiply this out, this times this, that will then give you this. Multiply this whole thing out, this times this, that will then give you this thing here. And then apply the same method here. Just note that, well, here you've got cos squared of an angle. Notice that in order for you to use cos squared, this angle here is always twice the size of this angle. Okay, so this angle here is always twice the size of this angle. Here we've got cos squared, and then this is our angle. We need twice the size of this. Twice the size of that will be cos 4x. So, well, apply this to this thing here. That will then take us to here. So notice that this angle is twice the size of this angle here. Okay, so anyway, that will then take us to here. Break this into two fractions. That's a half, and this thing here, that's this thing here. So now this one take away a half, that's a half. So now integrate it. Integrate this, that will then give us this. Integrate this, so this is your angle here. Integrate it, it will then give you this thing here. And now multiply this out, this times this times this. So your final answer would be this thing here. Okay.